Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in chemistry, and this pertains to the empirical and the molecular formula. But basically for this discussion we will limit ourselves to the empirical formula. Now in this case we are going to learn that apart from the elements or the atoms that we discussed as a basic building block of elements or substances, we're going to see that the empirical formula also is another way in which we can be able to represent a combination of these specific elements, which form of course what we call compounds. So in this case, thank you and welcome. So as I've said, we're going to look at the concept of empirical formula. And in an essence, this of course is a formula that is the simplest part of a formula of a given substance, which gives the elements present in that simplest ratio. So I've talked about the concept of an element in this case, and then we said that of course an element contains a substance which has got similar basic building blocks, of course, that we call atoms. And atoms of different elements can be represented using specific symbols. For instance, if I say an element like carbon, and I can represent carbon using the element, the letter or the symbol C, whereas an element like aluminium can be represented using those specific letters. So in this case, of course, we're going to see how different the concept of elements being represented using these two different kind of symbols. So there are cases whereby when there is a chemical reaction, different compounds can be formed, which of course can also be represented using different symbols. So in that case, a compound is a combination of more than one element. That's maybe two elements. For example, if I combine carbon with another element that has got this symbol, then I'm going to get a product of that kind or that nature. So for that case, this undergoes a chemical process in order to form that compound, that carbon 4 oxide. So in this case, when we talk about that particular compound that is represented by this kind of a formula, or represented using this combination of letters, this is what we call a formula. So this is what we call a formula. Now in this case, we have two different types of formula. The first one is empirical formula and the molecular formula. Now empirical formula basically refers to the basic formula for a compound, and therefore we're going to give it a definition as empirical formula. So we define this one as the simplest formula of a given substance. It gives the elements present in their simplest ratio. So this is the simplest formula that gives the elements present in their simplest ratio. So in this case, which means that's the simplest representation for elements. So now suppose we have an element like this. This one is, we're going to, this is a gaseous state. Of course, in gaseous state, we're going to refer that one to as a molecule of carbon 4 oxide. So suppose we have maybe this molecule in form of, or maybe there's a coefficient that is referring to these two volumes of this particular molecule of two quantities, then this is going to form a different kind of formula that we call a molecular formula. But when we have the omission of that, the simplest formula that can represent that one is going to refer to as the empirical formula. Now this empirical formula is obtained from the mass percentage of elements in compounds, and the mass percentage refers to the part of a percentage of a whole. So which means whenever this empirical formula is found like that, we can use the masses, the respective masses, and this is the formula masses of this specific component that is making that compound in order to represent these elements. That's in regards to the percentages composition or percentage composition of these two respective elements, and therefore that is what is going to form our basis for the empirical formula. Now there's a specific procedure that we're going to use in order to obtain a empirical formula given specific information. Now we're going to look at a procedure that can be able to assist us in trying to find the empirical formula of a substance, and this is going to use these of course percentage masses that we have already talked about. So in case we have an element that is 100 grams, so this implies that a fraction of this element is going to be represented in terms of percentage. Now that we know that a ratio of a particular quantity over 100 is what we refer to as a percent. So therefore, a fraction of a substance that is containing 100 grams of that substance can be represented in terms of percentage. So in this case, this is the concept that is going to be exploited in this discussion. So we shall have a procedure for determining this empirical formula. So the first one is, and one want to determine the empirical formula, you determine the number of moles of each compound or element. So the number, so first determine the number of moles of each compound. So in this case, we have talked about a compound because there are some cases whereby we might find an element containing crystals, like crystals of water. So therefore, we're going to make an element X containing crystals of water that can be represented as such. So that is why we need to find the moles of each compound, or maybe we're going to look at it as each element as well. So number 2, we're going to obtain the mole ratios by dividing the moles obtained in the first procedure by the simplest molar quantity. So we can as well obtain the ratios. So this basically refers to, okay, you obtain the mole ratios for these individual elements or compounds that are making up this substance. We can obtain the mole ratios by trying to divide these moles, the quantity of moles that we have obtained, by the smallest molecular quantity that is appearing across all these other quantities. So for that case, that is the simplest, any quantity of moles that are appearing for these respective elements in the compound. Then we divide by the simplest or the smallest quantity in order to obtain the mole ratio. And then the last one procedure that we're going to find is to round off the values to whole numbers. So therefore, lastly, we're going to round off the values obtained to whole numbers. So the values obtained for all these whole numbers are going to appear as subscripts for these symbols, and therefore they are going to represent the amount or the quantities or the percentages of those particular components in that compound. So I'm going to use a sample question in trying to illustrate this concept of empirical formula that we have talked about, and it's going to assist us in trying to find out how one can be able to obtain an empirical formula given specific data. So therefore, I'm going to write that one on the board. So this is our sample question, which states that the elemental analysis of a pure compound isolated from tea leaves gave the following results. The first compound, which is carbon, is 49.48%, and then hydrogen is 5.19%, and then we have nitrogen, which is 28.85%, and then we have lastly oxygen, which is 16.48%. So therefore, given the above data, we're going to use the procedure that we have listed for obtaining the empirical formula using our chart or a table, which is going to make it easier for us. So here I'm going to indicate the element, and then next I'm going to put the mass, and next I'm going to have the ratio, and then lastly I'm going to have the empirical formula. So in this case, the information that I've put here is going to assist me finding different ratios that we talked about, which are representative of the specific elements present in this analysis. So I have the first element, which is carbon, and then the second element is hydrogen, the third element is nitrogen, and then lastly we have oxygen. So in this case, we're going to determine the number of moles of each element by trying to divide the percentages by the relative atomic masses of each respective element. So we have been allocated the percentages by mass of this element as for carbon, 49.48, and then for hydrogen, 5.19, and then for nitrogen, 28.85, oxygen is 16.48. So these are the respective percentages by the mass by percentages that is appearing for this from this analysis, and therefore the ratio we said we're going to divide it by the relative atomic masses of each individual element in order to find the quantity. So we are going to have 48.48. Carbon has got an atomic mass of about 12, and then we have hydrogen, which is 5.19, atomic mass of 1, 28.85, nitrogen is 14, and then we have 16.48. Now for oxygen it's going to be 16. So therefore I'm going just to include another table here so that it can be able to give us the mole ratios. So we are going to the second, of course, the procedure. From the second part of the procedure, they say obtain the mole ratios by dividing the moles obtained from this ratio by the smallest molar quantity. So in this case, we are going to find that this one is going to give us 4.12. So these are the results for this 4.12. And then the second one is going to give us 5.19. This is the results from the previous table, the previous part of the table. So this is basically this row. These are the products for these rows from the division of these quantities that we have listed. And this is going to give us 1.03. And therefore, if you try to look across this, these are the mole ratios. It's going to give us the results of this, and then lastly we divide the moles by the smallest molar quantity. So the smallest molar quantity in this is this one, which is 1.03. So we divide across by this specific smallest mole ratio, and this one will give us 4, 5 to 1. So the last one basically represents the smallest, represents the simplest formula for a given substance, which is giving the elements present in the simplest ratio. So in this case, we are going to see that therefore, if our compound contains of carbon, hydrogen, nitrogen, and oxygen, so they are going to have subscripts bearing this number. So for carbon we have 4, for nitrogen we have 5, for oxygen, for hydrogen we have 5, for nitrogen we have 2, and then the last one we're going to have 1. So in this case, this kind of formula is what we call an empirical formula of this compound, which consists of the simplest ratios of elements in that formula. So in this case, this is how we're going to treat other data or data from the analysis, like the one that we have used above, in order to obtain the empirical formula of substances that we're going to encounter maybe in other set of problems that we're going to do in chemistry, especially in analysis of maybe compounds. So that is it for today. Thank you guys. Bye. God bless you.